Bon dia a tothom. Anem a donar pas a un altre seminari d'aquests conjunts entre la Universitat amb la Facultat de Ciències de la Terra i el Geociències Barcelona. Per mi és un dels més grans plaers presentar dos... Són més aviat dos amics, ja no són companys de feina, són amics de treball a les Azores, que fa més de 11 anys, 12 anys, sí, 12 anys que anem treballant junts i esperem que per molts anys. Per mi és un autèntic plaer presentar-vos al Pedro Rasposeiro, és investigador postdoc a la Universitat de les Azores, a CDO, que si em feu dir-vos que és el CDO, és un centre de recerca d'excel·lència annexat a la universitat. Vale? Ell és biòleg, no pot ser el món perfecte, no podem demanar... Ja sap que tot va amb tot el carinyo del món, va tot amb tot el carinyo del món. Ja ho sabeu que alguna en tenia que deixar anar. També... Bueno, ja ho sap que és amb tot el carinyo del món, que jo me'ls estimo moltíssim i m'estimo moltíssim els biòlegs. Sense els biòlegs nosaltres no faríem res. I la cosa és... Vale? Ahí. Vale? No, les coses com siguin. A veure, les coses com siguin. Vale? Ell farà la primera part de la xerrada i la segona part de la xerrada us la farà Vítor Gonçalves, que està sentat aquí, que també té la petita pega que és biòleg. Ell és professor titular a la Universitat de les Azores. Vale? Són dels grans especialistes de les Azores. Jo treballar amb ells és un autèntic plaer, la veritat, perquè sempre estic aprenent coses d'ells. Són els que estan portant tot el tema de la monitorització dels llacs de les Azores, que n'hi ha més de 80, amb tota la directiva marc de l'aigua, i estan fent un treball absolutament fabulós allà dintre. Llavors, aprofitant que estan treballant i es coneixen les illes com si fos pràcticament el palmell de la seva mà, vam estar fent tota una sèrie de treballs a nivell paleolimnològic, que és el que us ensenyaran ells en aquesta part d'aquí. Como sé que no vas a falar portugués, no. The talk will be in English, but like that it will be easier for everybody. Okay. If you have any question, just don't hesitate to them, because I'm sure that you will learn, and me as well, will learn quite a lot of things about them. Okay. So, as you wish, Pedro.
Thank you very much.
Yeah.
Thank you very much, Santi, for the kind words for the introducing us, and also for us is a pleasure to be in here. So that's why we came here to Barcelona so many times. It's a second home for us, and thank you very much for receiving us, and also the people that take the time to get to see the presentation. So today I'm going to present something about what has been done on the Azores on terms of the paleolimnology. Of course, all this area of study in the Azores cannot be done without a lot of persons that I want to thank. It's not working. No. Perfect. So all of these people are involved all in this kind of work. And as you know, most of human activities have transformed and managed ecological systems that drive to an ultimate acceleration contemporary ecosystem transformations. And because of that, the changes are causing biodiversity loss at an unprecedented rate, altering the ecosystem function in local climates, constituting a threat to human welfare and ecological stability. So oceanic islands are considered most of the times unique models or excellent models for ecological, evolutionary, and global change as one question, as one thing that humans have recently occupied these islands. So they are very far away from the mainland, as you can see here in the Azores, an excellent oceanic island. So it's more or less 1,040 kilometers apart for the mainland, for Europe in this case, and 2,017 kilometers apart from the America. And it's very recent, it's in the triple junction of the plates, here in the triple junctions. So the islands range from 4,000 to the youngest island of Pico, 25 million years. And they are very fragile ecosystems due to climate change, anthropogenic disturbances, stochastic events, biological effects. So all these characters make this island unique and a perfect laboratory to study how humans affect the ecosystems. So aligning that to the paleolimnology, because most of the time now we start the monitoring, as Santi said, like 25 years ago, but we don't have long-term data. So they are essential for understanding the environmental and the ecological problems. But lake sediments, all these records of the past lake conditions, the terrestrial conditions, the climate conditions, and using the multi-proxy approaches, we can provide a unique historic insights to understand modern lake status and quantitative evidence basis for restoration and conservation actions. So, as you all know, the lakes hold the sediments here, stratigraphic constraint in here, so the modern on the top and the older on the bottom. And using a lot of proxies like charcoal, pollen, diatoms, cladocer, cryonamids, also some volcanic ashes, RF analysis, among others, we could do some climate reconstructions, land use reconstructions, water levels, species introductions, and some more. Okay, so in the Azores are 9 islands, as I show you, but there are 88 lakes distributed in 5 islands. So, and the lakes are fundamental to support global biodiversity heritage and provide the key systems for ecosystem services. That's why we are in the decade of restoration and are the main goals for the United Nations Sustainable Development Goals, as you can see in here. So all starting the Azores, the first work in paleo was made by this guy, a Swedish guy that came to the Azores in vacation, but he collected a lot of sediments, and he's very curious because he went to most of the islands and core all these lakes with a Russian core, all these lakes, and they give the first information for the lakes. So for San Miguel, for instance, Lake Fugu is not suitable for coring because the dating is completely strange. Like Lake Azul is suitable for coring. This kind of information for San Miguel, Terceira, Pico, and Fayal. And Fayal is already said is not suitable for coring. After that, also go to Flores and to Corvo. And I think this is very interesting because he tell in this is very suitable for coring. The Caldeirão is the big crater that we can see in here. Oh, sorry. This one is said is very suitable for coring, and we have now start to work on this big lake. Another example, the first one with were done by Jacqueline with the pollen and tried to answer a question if the Slagialis craussiana was at the time was very discussed if they are native or exotic for the Azores. Most of the people, some part of the people defend it was native for the Azores, and the other part they argue that were exotic species for the Azores. And doing this kind of looking to the pollen, Jacqueline can see clearly that Slaginella craussiana was present all along the cores in Flores, more or less 3,000 years apart. So he completely said this was an endemic, native species. Okay, so also contributions for the quality of the Azores was then the first PhD that reached some of these topics of the paleolimnology was done by my colleague Vítor, and he starts to see what kind of changes the diatoms that is one of the major indicators for the water frame directive, try to establish the reference conditions of the lakes and start to digging a little bit more and try to see what kind of changes starts to appear on the diatom records all over the time, and try to calibrate to develop the indexes for assess the quality of the lakes. So after that, we start to work the collaboration here with Santi, Alberto, and Olga also is in here, and start to study more lakes. In this case, in Sete Cidades São Miguel. And one of the works that we have performed and tried to see the introduction of non-indigenous species. In this case, fish. Why fishes? Because in the Azores, most of the lakes that are not connected to sea or have a stream that is connected, because all of the lakes was fishless before 1991. Only the native fish that we have is in Gila, the eel, but is only present on the streams. After that, we have some historical records that they introduced the fishes. In this case, the golden fish in here. For most of the cases was the how do you call it, the priests, the monks that introduced them on the tanks to control the mosquitoes from the tanks for the water quality, and there are descriptions with the introduction of this fish. And after that, more close to the end of the 90s, they start to introduce a lot of fishes in the lakes to recreation process, to fishing, and so on. And more recently, try to control, to introduce the trop predators like the pike, try to control the other ones. So we publish on these thematics. What you can see in here is clear when the characterization using chironomids in this case and some organic matters, we can see clear that the community before the introduction of the fishland zone, we have a lot of chironomid predators. They are chironomids predators and free livings, but when we introduce the fishes, are a complete transformation of the system, because we lost one of the main components of the food web, the secondary chain in here, the zooplankton. Most of the fishes eat the zooplankton, and was a reversion on the food web change, and completely increased the grazers, and also because of the feeding strategy of the fishes completely transform the lake food webs. After that, more recent works that are published, also Simon Corner that published in the Azores, Valentin Hull also in the paleolimnology, we can see changes on vegetation dynamics, as you can see in here. So depending on the island and the altitude of the island, the different impacts that we have in the catchment, we can see different changes on the vegetation dynamics. So for instance, in here, when the porkies arrive, we have completely changes on the vegetation, interactions of the exotic species as cryptomeria. In here, in Sete Cidades, we can see clearly because of the lack of wood that we have, and so on, so on. So because of that, we can see a lot of evidence reconstructing this, and using a lot of indicators of human disturbance, we also start to see that human activity in the Azores was quite before of the official date of the Portuguese, and using a lot of proxies as the pollen, the charcoal, the non-polymorphous, the sterols, we do a lot of combinations, and we can see that the official colonization of the Portuguese, this one, we can see changes of human activities before the human colonization. So more or less 17 years before the official date of the Portuguese, starting with the first appearance of the mammals, as you can see in the stigmas tunnel here in the red ones, but also with the presence of the charcoal in Caldeirão and in Pico. And after that, a lot of other indicators start to appear, first defined by the copersonal ear in Peixinho, but also the plantation of Cerealis secale in here, but also a drop of vegetation in here and here and here. So also we use a lot of indicators and try to see the human colonization was clearly before the official records on the island, and sometimes drastic transformations on the landscape because they are synchronic and spread all over the islands. So also we also do some reconstructions of the climate, as you can see in here in the last papers that we produce, and mostly local climate change. We can see how the climate is variating and affecting the lake systems with the drop and the drop of the water or the increase of the water on the lakes, and after that with the ecological impacts that we can see in the biological communities. So I don't go enter too much on this detail because Vítor will explain a little bit later how human factors, climate and internal factors are affecting the lakes on the Azores. So it's going to be his talk. But we have now new opportunities to explore. So we have a lot of data, we have a lot of islands completely sampled with a lot of proxies already ongoing, or most of them are finished the process. So we have opportunities on climate change, temperature reconstruction, pest trophic interactions, toxin detections, and ecosystem services. So the first one, the global climate change, we can see clear that in the Azores, more or less in the 1980s, the temperatures start to increase, as you can see. So also in one island in Ponta Delgada, that is São Miguel Island, and in Santa Maria, that is another island of the Azores, is more or less synchronic, the increase of the temperature more or less on the 1980s. When we look to the profiles of the lakes that we are started now to develop a little bit more, we can see a synchronity of the records, and probably is related to the climate change. So now we are start to explore these kind of relationships all over the islands, all over the records that we have collected. Another one is also related to climate, is temperature reconstructions. We are start to using the chironomids and try to do some transfer functions to try to evaluate the temperature reconstruction and try to see how the temperature fluctuates along over the past in here, but also use it the chironomy, that capsules, and try to see the precipitation. We start now to explore a little bit more these kind of works and try to doing some precipitation and temperature reconstruction for the Azores is very important because the Azores is located in one of the poles of North Atlantic Oscillation, that is one of the main modes of the climate. Another one that we are start to working also is the detection of toxins using the pigments and try to see what kind of cyanobacteria and compounds that are present in the sediments, and try to see if that cyanobacteria are that were present were toxic in the past, and try to see how if they are produced, if they are producing, what kind of climate conditions or what kind of anthropogenic conditions are triggering this kind of production of the toxins, and try to modulate these to the future. So this is the future directions that we are working here in the Azores. So reference condition baselines, and after that try to see the direction of the change, the time of the change, the extent of the change, what kind of drivers are getting over there, what the mechanisms behind these changes, and what we can see and try to apply these to ecosystem services, biodiversity, and some risk assessments, of course. So I want to thanks very much for your attention. Thank you very much. If you have questions, please. Thank you.
Thank you, Pedro. I think if you agree that we can leave the questions for at the end. So it's fine for you, Vítor.
Terminar a partilha, ¿no? Dejar de compartir. Y de estar compartiendo. Bueno, voy a empezar un poco en mi mejor castellano, perdón, pero agradecer a Santi, a Alberto, por nos acoger aquí, por nos invitar a estar aquí también. Para nosotros es un placer siempre, porque como distante es verdad, estamos entre amigos, no entre colegas de trabajo, entre amigos. Y para nosotros, pues, ha sido siempre un placer desde 2010, cuando empezamos este proyecto conjunto, o varios proyectos conjuntos. Ha sido muy importante para nosotros, porque a la posibilidad de crecer científicamente dentro de un grupo mucho más potente que lo nuestro, ¿vale? Pues muchas gracias por todo, por la amistad, muchas gracias por venir, estar aquí. Also for the remaining audience going on live, seeing us, so thank all for being here. Okay, Pedro already presents the main aspects that we have been studying in the Azores, so I'm going to focus my presentation in a more specific area. And then, if you allow me, in the end, I would like to present a little bit our university and inviting everybody, if you want to go there, you are welcome at the University of the Azores. Starting on my presentation, as you can see in the title, some of the studies that Pedro presented allow us to show that some lakes have start to change very quickly, and there was a very rapid ecological shift. And what are the implications of these shifts in terms of lake water quality, ecological services, and management of water bodies? As you know, I'll go briefly on this. So lakes are, although more or less closed systems, they are complex. They have the interaction between the lake water, the lake bottom, the precipitation, the human activities around the catchment, and the internal processes are also important. Lakes are not only dependent on what's happening on the basin, but also inside with the biological interactions, with the process of the organic matter, the inorganic matter, and so on. So a lot of complex process occurs inside the lakes, and all of them contribute to the status of the lake and the function of the lake. And especially anthropogenic impacts are recognized as major problem in freshwater systems. We know that freshwater systems is among the more stressed environments on Earth, and because people are used to live around lakes and streams, so human impacts from agriculture, from industry, from global climate changes will affect the process inside the lakes, and have a lot of impacts that probably all you know as well as me. And global climate change is now as also a great concern on lake conservation, because it changed the hydrological cycle, it changed the acidification pattern inside the lake, and this can lead to also changing the distribution of species. So ecological systems inside the lake will be affected by climate change. But how anthropogenic and climate change interact, and how is the rate of the contribution of each of these main process in the lake conservation? That's something this also all the time is hard to understand. As Pedro said, in a system like the Azores, in an area where anthropogenic impact is expected to be lower and more recent, maybe we can disentangle the impact of climate and the impact of anthropogenic activities. Lakes are highly sensitive to disturbance on the catchment, on the lake, and the equilibrium of the ecosystem is quite sensitive. So changes can have a huge impact on lake system, and the resilience, it's sometimes very low. But it depends a little bit on the system, okay? It's not straightforward. Using a paleolimnological approach will allow us to go back on time, as you know, and also allow us to get information on times that we don't have instrumental data. And that's very important to have a broader perspective of the understand of how the ecosystem has evolved, and what was the baseline, and what was the baseline conditions to understand how can we, in terms of management of the system, what can we expect on applying restoration measures or restoration actions. The Water Framework Directive has a goal of getting a good status for every water body. All water body was on 2015. We are now in 2023. We are not getting there. And why is that? We, as Santi said, in the Azores, we are responsible for the monitoring networks and biological elements, of biological quality elements. And one of the problems is some lakes, although the government has applied a lot of restoration measures, we are not seeing an evolution in the system. What's happening? What can we expect? What kind of measures can we increase to allow a restoration of the system? We are not sure. Okay? In some of the lakes, we don't see this kind of restoration in the system. This is one of the lakes that Pedro showed before. It's Funda Lake in Flores Island. Flores Island is one of the smallest islands in the archipelago. It goes on the western group. It's on the American plates. It's volcanically stable. But the population of the island is around 4,000 people. And most of them, and as in all islands, are concentrated on the shores of the islands. The central plateau of the island, okay, is covered with vegetation. As we can see, we don't expect huge human impacts. I have another picture of the catchment, so completely forest, although there was a change in the vegetation during the past, as Pedro showed us. Now it's not a natural vegetation. A lot of invasive species are present covering the bottom, but it's completely vegetation covered on the landscape, no animal, no human activities or important human activities inside the catchment, although the system is now eutrophic and blooms of cyanobacteria are frequent and sometimes all along the year with toxic species. And so low oxygen concentration at hypolimnion, low transparency, high turbidity, high phytoplankton biomass, average chlorophyll A around here between 30 and 4 micrograms per liter. So it's a eutrophic system nowadays. But how does this have changed its eutrophic? How long it is eutrophic? We don't know for sure. So we have been collecting a sediment core from this lake in 2017, and the register covers more or less 1,000 years, and we have performed a multi-proxy analysis, including biological elements, geochemical, organic matter composition, elemental composition, isotopic. So we are able to reconstruct more or less the main composition of the system and the main forcings or drivers of the ecosystem change. In terms of biology, we study mostly diatoms and chironomids. I study most diatoms, Pedro chironomids, and our colleagues in Barcelona and other areas in other groups in Spain also, and in North America, have studied other proxies, okay? Well, but using mainly these and using also pollen, not as a driver of system change, but to know when the people have started to change the catchment. And from the pollen record, you see that deforestation started more or less on the 16th century, okay? In 1500 years ago. We have a huge decrease in the forests, in the most representative species of the mountain forest, that's the juniper, Ilex parado, and that also myrcene and other species disappeared, and the invasive species start to arise, like the hydrangea. And also we saw that in terms of charcoal, so they are burn and slash, or slash and burn process inside the catchment. We see that the increase in charcoal is at the same time as decrease of the forest and the appearance of the coprophilous fungi, Sporomiella, showing that the animals were introduced in the catchment, and now we have a change in the catchment. So more or less 500 years ago, the starting of the change in the vegetation in the catchment. And when we look at the elements in the water, we see also that more or less at the same period, we have changes, well, a little bit earlier, start to see huge changes in the composition of diatoms and also in chironomids. And the change mostly change from benthic diatoms to planktonic diatoms. So we expected or an increased level of the lake, or also an increase in the trophy of the lake, change of more oligomesotrophic species to more eutrophic species like Aulacoseira granulata, Aulacoseira ambigua, or some fragilarias also in the system, okay? And the same happens in chironomids, okay? More or less at the same period, we have this disappearance of the free leavings, and the tolerant to low oxygen levels start to increase. So we have an indication of a huge change in the community. But what drives these changes? Well, see that human impact is very important because these changes are at the same time as the changing in the catchment, the deforestation and introduction of the animals. But this happens 500 years ago. Nowadays, we don't see animals anymore in the catchment. They start to reforest the catchment. Could the lake recover from this situation? Well, when we look at the combine all the three records and the geochemical and isotopic data, we saw that we have mainly three phases. A pristine phase or baseline conditions, as we saw, before the human arrival to the catchment and before the human impacts. Then we have a transition phase, okay? And then we have the more recent phase. Well, diatoms are a little more detailed. They have shown us smaller differences, but mainly we have three phases that are, you can see in the isotopic signals of carbon and the nitrogen. They are determining more or less these changes, the nitrogen signal, changing from phase A to phase B, and then the carbon from phase B to phase C, okay? So we have three phases. It appears that there was a shift in the lake system in the 15th century, in between 15th and 16th century. In a period of 200 years, the lake changes from a oligo-mesotrophic system to eutrophic system. And it stables during all this period, from the end of the phase C until the present. And what was the main drivers during those phases? What is supporting this kind of situation? We analyzed the environmental drivers, separating them in three groups. One, an indication of the climate. We use climate simulations and climate variabilities to understand the impact of climate. We use the internal process. We use internal aquatic data to understand what's happening in the system, using nitrogen variation, isotopic variation. And then for human activity, we selected changes in the vegetation cover in the catchment. And we saw that in phase A, most of the system was controlled by internal process and climate. So climate and internal process was the main drivers establishing the composition, the function of the system, both in diatoms and in chironomids. Chironomids are more sensitive to climate, and diatoms to internal process. Nutrient recycling, that is more need for diatoms for algae grow. In the transition phase, in phase B, what we show as the human drivers are essential to the change in the composition. So human impact during that period completely changed the composition and the function of the system. Although climate also represents an important situation. And this period is a transition between medieval climate anomaly and Lea and the Little Ice Age. So a period of unstable climatic conditions. The synergic effect between the climate changes or the climate instability and human impacts will increase the runoff of nutrients to the lake, the transportation of sediment to the lake, the increase in turbidity, and all that drove the system to a more eutrophic system with a stratification, increased stratification, also in increase in lake level, increased stratification, decrease in oxygen in the hypolimnion, and now we get to a linear, to a stage that the nutrient recycling inside the lake starts to be the most important, and that's the shift to phase C. On phase C, we see that again, the climate and internal process are the main drivers. We don't have information for chironomids due to introduction of exotic species, as Pedro mentioned before. The introduction of fish will kill all the chironomids. We don't have chironomids on the recent years of the record. But in diatoms, see that humans are no longer a major driver for lake system. Now the system is maintained by internal process and climate. Okay, so it's the recirculation of nutrients inside the lake due to an anoxic hypolimnion that we still have nowadays. It's recycling nitrogen and phosphorus and creating this eutrophic dynamic in the lake that is stable during the last 300 years. We can see clear this on this graphic. Okay, on phase C, climate factors as the precipitation, the Eastern Atlantic anomaly, and the now situation is constant during this period and it's controlling the system. We don't have impacts on the vegetation, so no human impact. The isotopic cycle of nitrogen is also constant, but in the shift period, okay, you have huge climatic variations and mainly the change in the system due to the human impacts in the catchment. And from there to the present, okay, during all this period, we have, sorry, I was on the right, this is phase A, B, and C, so the transition is here. And then nowadays, from the last 400 years, more or less, we have a stable situation, a eutrophic system. What implication does it have? So what can we expect? We don't have many human impacts in the catchment. When we are working on the river basin management plans for the Azores, we started on 2013, and now we are in the third phase, as all of other countries in Europe, in the third phase of management plans. And we see what measures can we propose to recover the system. And we say to the manager that it's not easy to recover this system. This system has been stable during the last 400 years as a eutrophic system. It's not something that started 40 or 50 years ago with increase in agriculture. The agriculture is not a problem now in the lake. The problem is the internal process, and the system is resilient to change. The recovering measures that has been applied are not resulting because there is an internal resilience that lasts during the last 400 years. Okay? So we have a pre-human impact, and first human impacts association with the transition between MCA and LEA will change the system to a new age, okay, where the system is completely stable. And that's the picture that also Pedro showed to you. The baseline conditions dominated by climate and internal process, a period with fast human changes in the catchment and the climatic variability, stability, and now present-day conditions, an eutrophic system that is stable through internal processes. So to conclude, I will say that this resilience of the lake are maintaining a eutrophication status that is difficult to revert. Okay? And anthropogenic impacts, although they were smaller, they lead to irreversible process in the lake. Okay? Now it's difficult to recover again. And although that was the only name, as I clearly show in the beginning, there are a lot of people doing this hard work on the field. These were the guys collecting the sediment here. You known very well, a lot of people that is here. But others not being in the field collecting the samples also contribute a lot to this work. Thank you.